last lecture we discussed about the and emission of light and Einstein prediction. Now today we are going to start three processes of light. So in this process, to the radiation of incident on medium, there are three quantum processes will be. First is absorption, second is spontaneous emission, third is stimulated emission. So in this absorption process, the of the incident radiation are absorbed by the atoms in the medium and atoms goes into the excited states. This process is called absorption. So in this absorption process, absorption can be causes the loss of photons. This process spontaneous emission of light will be emitted in the direction in the all directions. So this process can be dominate the conventional and natural source of light. Second is spontaneous emission. In this spontaneous emission of process, the atoms in the excited state returns back to the ground state. In this process, its own energy will be generated. So this causes the emission of phenomena will be fall into the difference of energy in the form of photons. So energy of differences causes the process of spontaneous emission. Third is stimulated emission. So in this stimulated emission of process, the atoms in the excited state suddenly goes to the de-excited state. So in this incident of photon, they fall into the ground state. So in this state, the emitting of the extra energy in the form of photons will be occur. So this process is called stimulated emission. In this stimulated emission, photons are in the multiplied and then related to other characteristics form will be occur. The light amplification phenomena takes place. This process can be dominate in the laser light source. So first in detail we study absorption. In this absorption process, the photons of the incident radiation are absorbed by the atoms in the medium and the atoms goes to the excited state. This process is called absorption. So see on a diagram. Diagram shows that the atoms in the lower energy level of E1 and it absorbed the incident photon. Photons present in the ground state and it suddenly jumps to the excited state E2 and transition process occur and that transition process is known as absorption. And see the incident photon h mu is equal to hv is equal to E2 minus E1. See the energy level E2 by E1. So in second absorption process will be after absorption phenomena E1 and even ground state to present atoms suddenly goes to the excited state E2. So in this phenomena occur absorption of incident of photon. So in second figure denoted the material of photons and in that process absorption the materials can be converted in the form of photons. So photons will be disappears from the incident field and adds to the population in the excited energy level E2. So it will be represented A plus HV tends to A dash, where A is A represented by atoms in lower state and A dash represent the atoms in the form of excited state. So when atom can be per unit volume, that upward transition from the lower level to the upper level per second is known as absorption of transition. So it will be decreases in the form of population lower level of E1. So it can be represented R absorption phenomena is equal to minus dN1 by dt, where dN1 is represented the population of lower energy level E1, and it will be in the form dN by dt is the rate of change of energy level of E1. So increases in the population in the form of upper level of energy level E2. So R absorption is equal to dN2 by dt, where R absorption is equal to minus dN1 by dt is equal to dN2 by dt. So in this process we get the after number of transitions will be occur when material can be instantly goes to the formation of photons. So in these processes the number of absorption of transitions proportional to the population in the lower level, and beam of light can be expressed in that case. So R absorption is equal to B1 2p of V in bracket close N1. So in this phenomena where B1 is represented by the constant of proportionality, sorry, B12 is represented as constant of proportionality, and P of V is represented the energy in the form of density. So the density of incident light. So N1 is the represented by population in that level. So in at thermal equilibrium, population in the lower state larger than in the higher state. So light propagates through the medium absorbed. So according to Einstein coefficient phenomena, the induced absorption can be form in the form of probability, and that we get the absorption phenomena can be occur in that particular medium. So thank you.